Okay, some comments on the lab about electric field and electric potential. These lines represent electrodes, and conductive paper allows to measure electric potential at different locations, and when you watch the video you can see the electrode on the left represents a positively charged plate, higher voltage, and on the left represents like negatively charged plate, and you know the electric field should be pointing from plus to minus, something like this. If these electrodes would have been infinitely large, electric field would have been uniform. In reality, it shouldn't. And one of your goals is to study electric field by measuring electric potential. And when you do that, so ignore this, and this is a decimal point, and the unit might change during the video, so you have to pay attention to all these details. For example, if we go to, let's say, so 9, come on, move on. All right, I don't care. So right here you can see how a person measures electric potential relative to the ground. Technically that's what it is. And you see there is some weird comma, you should ignore it, and at some point your unit changes. Well, anyway, your goal is to collect the data and fill in this table, and for that you need 4 columns, because you need to take data for 3 different regions. If these are electrodes, first region, second region, third region, it's called edge, center, and one just in between. And of course you also need to use some kind of a distance, and for that you have options. Normally you have to draw the x-axis and choose the origin. That's a natural choice. In that case, when you measure distance from the left electrode, that will automatically give you the x-coordinate. But also some people have measured distance from this 0. That doesn't affect the data in general, but technically in that case, if your choice is not kind of common, you should state the choice of your origin. And here, if you name your columns like x centimeters, x, I'm gonna use my names, V1 volts, V2 volts, V3 volts, volts. Now you're taking data, and could have been something natural, 0.05, 1.5, 2.5, oops, 3.5, and now this like 10, 9, 8, 7, and this could have been 11, 7, oops, I wanna 5, 3, doesn't really matter, 11, 4, 1, 0. All numbers are made up. They needed to illustrate how you sketch graphs, so you don't use anything related to uncertainty because you don't know how to treat uncertainty. And if you don't know how to treat uncertainty, you have to ignore uncertainty in any ways. And well, we need 3 columns. 1, 2, 3. Now you can try to do a fit. And what choices do you have? Quadratic, proportional, linear. And what does fit do? The fit should fit your data. So here there's only one good fit. That means you have to rethink your choices. What are there? You cannot just bluntly choose an equation and believe it's going to be correct. No. Well, in my example, my third set of data is not very accurate. So I want to make all just linear. Why? Because there is another very important reason to choose the linear. I'm going to talk about it soon. But which is which one? The one is the best. I want to make this for now quadratic because some students did that. And what you can see in my fit, this coefficient is 0. And in actual experiment, this coefficient would have been almost 0. What does it mean? It means, again, this is the wrong fit. You have to use the linear. Or if you did use quadratic, in that case, you would have to use a different coefficient, not A. Well, but what information should we extract? Number one, we have to analyze a specific set of data only related to the region close to the center. And in my case, this is, well, I think this one, again, doesn't matter. And then now I know that the y variable represents electric potential and x variable represents that x coordinate or distance measured from the electrode. What does A represent? Many students didn't even ask this question. You need to calculate the magnitude of electric field. Yeah? And you just write, for example, E equals -1. And first of all, magnitude cannot be negative. So if you don't pay attention to the question you need to answer, that's not good. More importantly, how do you know that this coefficient is related to electric field? You need to use a specific physical correlation, an equation. And for that, well, many students would write this. And if I ask what is V, potential, what is D, distance, in that case I can say, okay, let's solve it for potential. And if your distance is equal to 0, and you're multiplying by 0, your answer has to be 0. But in reality, your actual initial value is not 0. So, either this is a wrong equation or you're using it wrong, or both. Well, this equation has a very specific variable. And the rule number 1 in physics, when you write an equation, you need to be able to say out loud the exact meaning of each variable. And this equation, E represents the magnitude of electric field, D represents distance between two locations, V represents voltage, magnitude of potential difference between these 2 points, and more importantly, they have to belong to the same electric field line, or it will not work. And of course, if you don't know all these elements, you can't use this equation. What equation do you need to use? Well, again, electric field is a vector, an actual, like an arrow bow with an arrowhead and feathers. You cannot input a vector into a cell of a table or into a calculator. So you need to make a transition from vectors to numbers. And for every vector, we only have several specific numbers. We can use magnitude, component, or an angle, certain angle. And in this situation, of course, we have to write how the x component of this vector is related to electric potential. And this is the equation you need to search in your notes, lectures, or on Google. And of course, you can solve this equation for the electric potential. So V final will be equal to V initial minus Ex times delta X. And rewrite it in a form similar to the fit you're using, y equals ax plus b. And of course, again, you know that y represents potential because that's how you set it. X represents distance, initial potential. And now, if you continue your comparison, only now you can make a statement, yeah, this A and the x component are related. A actually is the slope, rise over run, slope, delta V over delta X, and of course you can see it's going to be negative, which is a good thing, because your x component for electric field should be positive. It points to the right. And that's what we see here, because if you solve it for x component, negative A, negative slope, it makes it positive. Now we have to read the next question. And the next question is about the electric field close to the edge. Yeah? So, first of all, again, magnitude, which cannot be negative, and if you write A equals -1, that's wrong. You don't answer the question you asked to answer. And your data tell you that close to the edges in this region, electric field has a slightly smaller magnitude, less than center, edge, center. Your experiment does not give you any information about the direction, so you should kind of say that, well, we don't have information, so close to the center, that's electric field, and here we've been measured electric field using potential differences, and it has a smaller magnitude. So if someone asks you, is electric field uniform, you have to be careful with this word, because in this region it is kind of uniform. It points in the same direction and has the same magnitude. But if the question is about electric field between the plates in general, well, it's not uniform, because electric field changes at least in magnitude. And of course, it is almost uniform, close to be uniform, because in theoretical case, when the plates would have been infinitely large, electric field would have been uniform.